Dinosaurs. These magnificent creatures ruled our planet for over 180 million years. They diversified into a stunning array of shapes and sizes, from the mighty Tyrannosaurus rex to the gentle giants like Brachiosaurus. Their reign seemed unchallenged, a testament to their successful adaptation and dominance. Then, 66 million years ago, it all ended. They vanished, wiped out in a cataclysmic event that marked the end of the Cretaceous period and the Mesozoic era. What could have caused such a sudden and complete extinction? This question has captivated scientists for decades, leading to intense research and heated debate. In the 1980s, a groundbreaking discovery provided a compelling clue about a cataclysmic event that reshaped our planet. A team of scientists, including myself, identified a thin layer of iridium in geological strata dating back to the time of the dinosaurs' demise, a discovery that would change our understanding of Earth's history. Iridium is rare on Earth, but abundant in asteroids, suggesting an extraterrestrial origin for this mysterious layer. This finding led to the hypothesis that a massive asteroid approximately 6 miles wide slammed into Earth, causing widespread devastation and triggering a global extinction event that wiped out the dinosaurs. This impact, now widely accepted by the scientific community, created the Chicxulub crater, a massive scar buried beneath the Yucatan Peninsula in Mexico, a silent witness to the cataclysm. The immediate effects of the impact were nothing short of apocalyptic, reshaping the landscape in an instant. The impact released energy equivalent to billions of atomic bombs, instantly vaporizing rock and unleashing shock waves that rippled across the planet, causing unimaginable destruction. Imagine the unimaginable colossal tsunamis engulfing coastlines, wildfires raging across continents, and the sky choked with dust and debris, blocking out the sun. The impact ejected trillions of tons of material into the atmosphere, shrouding the Earth in darkness and causing a prolonged period of global cooling, a phenomenon often referred to as a nuclear winter, which drastically altered the climate. This impact winter would have had devastating consequences for life on Earth, leading to a mass extinction event. With sunlight blocked, photosynthesis would have ceased, disrupting food chains and leading to widespread starvation among plant and animal life. The impact also released massive amounts of sulfur into the atmosphere, which combined with water vapor to form sulfuric acid aerosols, further complicating the environmental disaster. These aerosols reflected sunlight back into space, further cooling the planet and causing acid rain, poisoning water sources and devastating ecosystems, leading to a cascade of environmental impacts. While the asteroid impact provides a compelling explanation for the extinction event, it is not the only contender. Scientists have long debated other potential causes that could have contributed to this massive die-off. Around the same time as the Chicxulub impact, another cataclysmic event was unfolding on the opposite side of the planet. This event was equally dramatic and had far-reaching consequences. In what is now India, massive volcanic eruptions were spewing out lava flows on a scale never witnessed before or since. These eruptions were part of a geological phenomenon known as the Deccan Traps. These eruptions, which lasted for hundreds of thousands of years, formed the Deccan Traps, a vast volcanic province covering an area larger than France. The sheer magnitude of these eruptions is hard to fathom. The Deccan Traps eruptions released enormous quantities of greenhouse gases, such as carbon dioxide and sulfur dioxide, into the atmosphere. These gases had a significant impact on the environment. These gases would have had a profound impact on Earth's climate, leading to long-term global warming and ocean acidification. The changes in climate were both immediate and long-lasting. The increased levels of carbon dioxide in the atmosphere would have trapped heat, raising global temperatures and disrupting weather patterns. This would have created a hostile environment for many species. Meanwhile, the sulfur dioxide released by the volcanoes would have combined with water vapor to form sulfuric acid aerosols, similar to those produced by the asteroid impact. These aerosols had their own set of consequences. These aerosols would have reflected sunlight back into space, causing acid rain and further disrupting Earth's climate. The combination of these factors created a perfect storm of environmental stress. The long-term effects of these volcanic eruptions would have been devastating for many life forms. Ecosystems that had thrived for millions of years were suddenly under threat. the gradual warming of the planet would have put immense stress on ecosystems, leading to habitat loss and forcing species to migrate or face extinction. The survival of many species was at stake. The acidification of the oceans would have been particularly harmful to marine organisms, dissolving the shells of shellfish and disrupting marine food chains. The ripple effects of these changes were felt throughout the marine ecosystem. The coincidence of the Chicxulub impact and the Deccan Traps eruptions has led some scientists to propose a controversial hypothesis. Could the impact have triggered or intensified the volcanic activity? This theory suggests that the seismic shock waves generated by the impact could have traveled through the Earth's mantle, destabilizing magma chambers beneath the Indian subcontinent, and triggering or intensifying the Deccan Traps eruptions. While this hypothesis is still being debated, it offers a compelling explanation for the seemingly simultaneous occurrence of these two catastrophic events. If true, it paints an even more dire picture of the end Cretaceous world, where the combined effects of an asteroid impact and massive volcanic eruptions created a perfect storm of environmental disasters that wiped out the dinosaurs and countless other species. The fossil record provides crucial evidence supporting the catastrophic nature of the dinosaurs' extinction. The rock layers below the iridium layer, representing the time before the impact, are teeming with dinosaur fossils. Above the iridium layer, however, dinosaur fossils are virtually absent, indicating a sudden and dramatic extinction event. The fossil record also reveals that the dinosaurs were not the only victims of this cataclysm. Many other groups of organisms, including marine reptiles, ammonites, and numerous plant species, also disappeared from the fossil record at or near the Cretaceous-Paleogene boundary, the geological marker for the end of the dinosaur era. This mass extinction event, known as the KPG extinction, wiped out an estimated 76% of all plant and animal species on Earth. Section 6. The Great Debate: Asteroid versus Volcanoes. The relative importance of the asteroid impact and the Deccan Traps eruptions in driving the KPG extinction is still a subject of intense scientific debate. The asteroid impact is widely considered the primary driver of the extinction, given the sudden and catastrophic nature of the event and the global distribution of iridium and other impact-related markers. However, some scientists argue that the Deccan Traps eruptions played a more significant role than previously thought. They point to evidence suggesting that the eruptions were already underway before the impact, and that their cumulative effects on Earth's climate and environment could have been sufficient to cause a mass extinction event even without the asteroid impact. Section 7. Beyond the debate: a complex interplay. The debate over the relative importance of the asteroid impact and the Deccan Traps eruptions highlights the complexity of Earth's systems and the challenges of unraveling events that occurred millions of years ago. It is likely that both events played a role in the KPG extinction, with the asteroid impact delivering a sudden and catastrophic blow, while the Deccan Traps eruptions created a prolonged period of environmental stress that made life increasingly difficult for many species. Rather than viewing these events as competing explanations, it may be more accurate to see them as interconnected factors that combine to create a perfect storm of environmental disasters, ultimately leading to the demise of the dinosaurs and many other creatures. Section 8. Lessons from Extinction: a warning for the future. The extinction of the dinosaurs serves as a stark reminder of the fragility of life and the devastating consequences of rapid environmental change. These ancient creatures, once rulers of the Earth, vanished almost overnight, leaving behind only their bones as a testament to their existence. While the events that wiped out the dinosaurs were extraordinary, they offer valuable lessons for our own time. Our modern world is undergoing rapid changes, and we must heed the warnings from the past to avoid a similar fate. We are currently facing a biodiversity crisis, driven by human activities such as habitat destruction, climate change, and pollution. These actions are pushing many species to the brink of extinction, threatening the delicate balance of our ecosystems. The rate of species extinction is estimated to be 1,000 times higher than the background rate, a pace that rivals the mass extinctions of the geological past. This alarming trend underscores the urgent need for conservation efforts and sustainable practices. The dinosaurs' demise teaches us that even the most successful and dominant species can be wiped out by rapid environmental change. Natural disasters, whether from space or Earth itself, can have catastrophic impacts. It also highlights the interconnectedness of Earth's systems and the potential for seemingly unrelated events to combine and amplify each other's effects. Understanding these connections is crucial for mitigating future risks and ensuring the survival of our planet's diverse life forms. As we grapple with the challenges of climate change and biodiversity loss, the lessons from the dinosaurs' extinction are more relevant than ever. We have a responsibility to learn from the past and take action to prevent a similar fate for ourselves and the countless other species with whom we share this planet. By reducing our impact on the environment, transitioning to clean energy sources, and protecting biodiversity, we can create a more sustainable future and avoid repeating the mistakes of the past. The fate of the dinosaurs serves as a sobering reminder of the consequences of inaction, but it also offers a glimmer of hope. We have the knowledge and the ability to change course and create a better future for all life on Earth. The question is, will we choose to act before it's too late?